one, we're going to determine whether the series converges or diverges. Let's use our test for divergence. So if we just take the limit as n approaches infinity of cosine of 1 divided by n raised to the power of n squared, what you're going to get is this is going to go to 0. So cosine of 0 is 1, and you're going to get 1 to the power of infinity, which is an indeterminate power. All right. Now, so what we're going to do is let y equal the limit as n approaches infinity of cosine of 1 divided by n to the power of n squared, and take the natural log of both sides of the equation. So this is going to give you ln of y equals the limit as n approaches infinity of ln of cosine of 1 divided by n to the power of n squared. Now, I'm going to use my properties of logs and bring this n squared down. So I'm going to put that in front right here, n squared, and take it off here. Now let's look and see what we have. This is the form of infinity times 0. So now let's go ahead and just rewrite this part as the ln of y equals the limit as n approaches infinity of ln of cosine of 1 divided by n divided by 1 divided by n squared. And this gives us the form 0 over 0. So now we're going to use L'Hopital's rule. Now that we have this form. All right, so let's do that. So we're going to do natural log of y equals, and we're using L'Hopital's rule. So put h, the limit as n approaches infinity, and we're going to differentiate our numerator. That's going to give me 1 divided by cosine of 1 divided by n times the derivative of cosine, which is going to be negative sine times 1 divided by n times derivative of 1 divided by n, which is negative 1 divided by n squared. That's your numerator. Your denominator is going to end up being negative 2 divided by n cubed. All right, this is going to equal, simplifying it, the limit as n approaches infinity, and this is going to be negative tan of 1 divided by n times, let's see, if we use this with this, we're going to get negative 1 divided by n squared times, and I'm going to multiply by the reciprocal, n cubed divided by negative 2. So this is going to, this part right here is going to equal n divided by 2. All right. So now what we're going to get, then I'm going to move this back in the denominator. So we're going to get the ln of y equals the limit as n approaches infinity of negative tan divided by 1 over n. And then I'm going to put this in the denominator, so I have to flip it back around. Right, this is 2 divided by n. All right, this gives you also 0, the indeterminate form, 0 divided by 0. So we have to use L'Hopital's rule again. So let's, I'm going to differentiate the numerator and the denominator. So let's do that. and we're going to get equals, with L'Hopital's rule, negative secant squared of 1 divided by n times negative 1 divided by n squared. Let me put the limit. Forgot the limit. So this is going to be the limit as n approaches infinity, and we're using L'Hopital's rule. All right, divided by negative 2 divided by n squared. This is going to give you ln of y, which equals the limit as n approaches infinity of, and we're dealing with these two right here now. So this is just going to give you negative secant squared of 1 divided by n divided by 2. And basically I'm just crossing those out. All right. Now this is going to equal negative 1/2. All right. From there, we have ln of y equals negative 1/2. So this is going to end up being e to the power of ln of y equals e to the power of negative 1/2. That means using your powers of logs, bring this y down. You get y equals e to the power of negative 1/2, which equals y equals 1 divided by square root of e, which does not equal 0. Therefore, the series diverges by the test for the divergence test. Thank you. Have a nice day. Bye-bye.